When working with electrical installations, ensuring safety and code compliance is paramount. The question of whether a zinc die-cast offset nipple requires the protection of an insulating bushing is a crucial one. The answer is yes. Let's delve into the reasons behind this requirement and explore the relevant standards that govern it. An offset nipple is a type of conduit fitting used to connect two electrical boxes or enclosures that are slightly offset from each other. They are commonly made of materials like zinc die-cast, which offers durability and corrosion resistance. However, the edges of these fittings, particularly at the point where the conductors enter or exit, can be sharp. These sharp edges can pose a risk to the insulation of electrical conductors. When conductors are pulled through a conduit system, they can rub against these edges. Over time, this friction can damage the insulation, leading to potential short circuits, ground faults, and even electrical fires. An insulating bushing, also known as a conduit bushing, is a protective fitting designed to be installed on the end of a conduit or fitting. Its primary purpose is to provide a smooth, rounded surface that prevents damage to the conductor insulation. These bushings are typically made of plastic or other non-conductive materials. By installing an insulating bushing on a zinc die-cast offset nipple, the sharp edges are effectively covered, creating a safe pathway for the conductors. This practice is not merely a suggestion, it is a requirement of the National Electrical Code, or NEC, which serves as the standard for safe electrical installations in the United States. The NEC addresses this issue in several articles. One key article is NEC 300.4. This section deals with the protection of conductors from damage. Specifically, 300.4. F addresses insulated fittings. It states that where conductors enter or exit a raceway, cable, or enclosure, they must be protected from abrasion. This protection is typically achieved through the use of fittings that are designed to provide a smooth, rounded entry point, such as insulating bushings. Another relevant article is NEC 314.17. B. This section focuses on the protection of conductors at boxes and conduit bodies. It requires that where conductors enter a box or conduit body, they must be protected from abrasion. This protection can be provided by a fitting that is part of the box or conduit body, or by a separate fitting such as an insulating bushing. In the case of a zinc die-cast offset nipple, the fitting itself may not provide adequate protection against abrasion. Therefore, an insulating bushing is necessary to comply with NEC requirements. It is important to note that the NEC is not just a set of guidelines, it is a legally enforceable standard in many jurisdictions. Failure to comply with the NEC can result in fines, project delays, and even legal liability in the event of an electrical incident. Therefore, it is essential for electricians and electrical contractors to be familiar with the NEC and to follow its requirements diligently. In addition to the NEC, other standards and best practices also support the use of insulating bushings with zinc die-cast offset nipples. For example, Underwriters Laboratories, or OWL, which is a widely recognized organization that tests and certifies electrical products, often requires that fittings be equipped with insulating bushings in order to receive UL listing. This means that if a zinc die-cast offset nipple is UL listed, it is likely that it was tested and approved with an insulating bushing in place. From a practical standpoint, the installation of an insulating bushing is a simple and inexpensive way to protect conductors and ensure a safe and reliable electrical system. The cost of an insulating bushing is minimal compared to the potential cost of repairing damaged conductors or dealing with the consequences of an electrical failure. Moreover, the time required to install an insulating bushing is negligible. It simply screws or snaps onto the end of the fitting. When selecting an insulating bushing, it is important to choose one that is appropriate for the size and type of conduit or fitting being used. Insulating bushings are available in a variety of sizes and materials to accommodate different applications. It is also important to ensure that the insulating bushing is properly installed. It should fit snugly on the end of the fitting and provide a smooth, continuous surface for the conductors to pass through. In summary, the use of an insulating bushing with a zinc die-cast offset nipple is not just a good idea, it is a requirement of the NEC and other relevant standards. These bushings provide essential protection for conductors, preventing damage to their insulation and reducing the risk of electrical hazards. By following these guidelines, electricians and electrical contractors can ensure that their installations are safe, compliant, and reliable. Now, let's consider some additional factors related to the installation and maintenance of electrical systems that can impact the necessity and effectiveness of insulating bushings. Firstly, the type of conductors being used plays a role. Some conductors have a more robust insulation than others. For example, conductors with a cross-linked polyethylene or XLP insulation are generally more resistant to abrasion than conductors with a polyvinyl chloride or PVC insulation. However, even with more durable insulation, the use of insulating bushings is still recommended as it provides an extra layer of protection. Secondly, the environment in which the electrical system is installed can also influence the need for insulating bushings. In harsh environments, such as those with high levels of moisture, chemicals, or extreme temperatures, the insulation of conductors can degrade more quickly. In these situations, the use of insulating bushings becomes even more critical. Thirdly, the quality of the installation is a key factor. Even with the best materials and components, a poorly installed electrical system can be unsafe and unreliable. When pulling conductors through conduit, it is important to use proper techniques and tools to avoid damaging the insulation. This includes using cable lubricant, avoiding sharp bends, and ensuring that the conductors are not twisted or stretched. Fourthly, regular maintenance and inspection are essential for ensuring the long-term safety and reliability of an electrical system. This includes visually inspecting conductors for signs of damage, testing for insulation resistance, and verifying that all fittings and connections are tight and secure. If any problems are detected, they should be addressed promptly to prevent them from escalating into more serious issues. Fifthly, consider the specific application of the electrical system. In some applications, such as those involving sensitive electronic equipment, even a small amount of insulation damage can have significant consequences. In these cases, it is particularly important to take extra precautions to protect conductors from abrasion. Sixthly, the size of the conduit and the number of conductors being pulled through it can also affect the risk of insulation damage. When a large number of conductors are pulled through a small conduit, the conductors are more likely to rub against each other and against the edges of the fitting. In these situations, the use of insulating bushings is especially important. Seventhly, always refer to the manufacturer's instructions for the specific fittings and components being used. The manufacturer may have specific recommendations or requirements regarding the use of insulating bushings. Eighthly, consider using alternative types of fittings that may provide better protection for conductors. For example, some fittings have built-in insulating features or are designed with rounded edges to minimize the risk of abrasion. Ninthly, the use of proper grounding and bonding techniques is essential for electrical safety. Grounding and bonding help to ensure that electrical faults are quickly cleared, reducing the risk of electric shock and fire. Insulating bushings can play a role in maintaining the integrity of the grounding and bonding system by preventing damage to conductors that are used for grounding and bonding. Tenthly, stay up to date on the latest codes and standards. The NEC is updated every 3 years, and it is important to be aware of any changes that may affect the installation of electrical systems. Similarly, UL and other organizations regularly update their standards for electrical products. Furthermore, the use of insulating bushings is not limited to zinc die-cast offset nipples. They are also commonly used with other types of conduit fittings, such as couplings, connectors, and elbows. In general, any time conductors are being pulled through a fitting with sharp edges, the use of an insulating bushing is recommended. Additionally, the color of the insulating bushing can sometimes indicate its intended use or material. For example, some insulating bushings are color-coded to indicate that they are suitable for use with specific types of conductors or in specific environments. However, color coding is not always standardized, so it is important to refer to the manufacturer's instructions to determine the meaning of the color. Also, while insulating bushings are typically made of plastic, they can also be made of other materials, such as fiber or metal. The choice of material depends on the specific application and the desired level of protection. For example, metal insulating bushings may be used in applications where high temperatures or corrosive environments are a concern. Furthermore, the installation of insulating bushings should be part of a comprehensive electrical safety program. This program should include regular training for electricians and electrical contractors, as well as procedures for inspecting and maintaining electrical systems. The goal of the program should be to prevent electrical accidents and injuries. Remember, the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical contractor before performing any electrical work. They can assess the specific conditions of the installation and provide recommendations that are tailored to the situation. Moreover, they can ensure that the work is performed in accordance with all applicable codes and standards. It is also important to note that the requirements for electrical installations can vary depending on the jurisdiction. Some states or municipalities may have their own electrical codes that are more stringent than the NEC. Therefore, it is essential to be familiar with the local codes and regulations before starting any electrical work. And keep in mind that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Always take appropriate safety precautions, such as wearing personal protective equipment and energizing circuits before working on them.